Давай.
Okay, hello everyone. Yes, we are live. This is Nikolai and Ilya. We organize.
Hi, everyone.
Hello. Sorry for the quality of sound today. It's like we have issues, but I hope you will understand everything. And this is Postgres TV Open Talks series. And today we have a great guest, Alexander Korotkov. Hello.
Hello.
Alexander is very active PostgreSQL hacker contributor with commit permissions, right? This is very important. It shows the level of involvement into the Postgres project. We met first many years ago in Russia when Alexander joined Oleg Bartunov's team to work on various performance and scalability related issues in Postgres, especially gist and gin indexes and so on. So Alexander made a career inside Postgres community working on these important problems. I think everyone is at some point is using these types of indexes and so on. And some time ago, Alexander left Postgres Pro to work on, I think, on maybe most challenging problems inside Postgres project, right? So we will talk about them today, but I want to apologize for not only for sound, but also for slightly wrong title we have on everywhere. I will fix it. We won't talk about wicked problems. We will, but we are going to repeat Alexander's talk he gave a couple of days ago on EDB Postgres Vision conference. And it's called The Future of Postgres, right?
Yes.
Am I right?
Yes.
Right, good,
yes,
good.
Absolutely, you're right.
Right. And you work on these problems like 4 years already, right? Like quite long.
Yes, already quite long. Yes, it's a long way.
Mm-hmm. And already have a lot of things done in OrioleDB project, which is available open source on GitHub.
Yes, it's available on open source GitHub. And we are now concentrated on improving. We are stop adding new features. We are concentrated on making the code base stable, on attracting more
users.
More users, more testing, more benchmarking to make sure we are stable. And we also now building a community of developers. So I have my own startup and we are doing some fundraising now. But in order to make an open source project successful, we need to make it developed not by single company, not by single startup. And I can't told you the names right now, but you will see that it will be soon developed by multiple teams from multiple companies. And this really excites me. Then you know, it's kind of raising a baby, right?
right.
Yes,
I know that.
Especially this is about open source. Is a kind of baby which can go himself or herself, right?
Right.
It can do not only that you do or you are.
Not as planned.
Yes. No, not something you put employees to do, but start its own life. Yes, that's really interesting and that's really exciting for me.
Right, and so today we are going to talk about future of Postgres in very technical context.
Yes, it's still technical, but it's a bit visionary talk.
Right.
From me,
because
this was a new experience for me at Postgres Vision because I all the time I gave hardcore technical talks, and this talk a little bit philosophical,
more high level.
Yes, more high level, a little bit of philosophical and visionary, but for sure you can ask me any technological question and I will answer everything. but I will repeat the same talk I gave at Postgres Vision.
Great, and we know that Bruce Momsen has talk called "Will Postgres Live Forever?" It's more like related to community and so on, and like probably your talk is more like slightly more technical and also interesting to discuss future of Postgres.
Yes.
Okay, great. Before we continue, I ask everyone who is watching. We see that more people are watching in this recorded session, but especially those who are right now watching us live, please share link to this talk in your social networks, because we want to grow our channel and bring more attention to it. And as you see, we previous episodes also we discuss very interesting topics, and we invite selected speakers from already selected lists, so it's like the best of the best. So
thank you. We're proud to be the best of the best.
Great. Before that's it. Let's switch to the talk. Please share slides.
Good. Okay. And can you see my screen now?
Yeah, it works.
Good. Thank you. Yes. So yes, it's the title slide. I think Nikolai already introduced me well. And as usual, I'm starting with a slide saying how great is Postgres, and we all know that Postgres is one of the most popular database management systems in the world. It's most loved relational database management system according to Stack Overflow survey, and it gets the DBMS of the year multiple times according to DB Engine rank, and that's great. We all love Postgres. Good. And the next slide says that we have a lot of different database management systems now. And I tried to find this picture in the Google, typing something like DBMS landscape and so on, but I didn't find it, and I have to draw it my own. Yes, so I just go to DB Engine's rank. I have copied the list, then a little bit of magic with regular expression to clean up. After that, the Python module word cloud, and voila. So this picture shows that a lot of database management systems. It's hundreds of them, and there are few very popular, and Postgres is one of the most popular database management system, but plenty of them. And each database management system is aimed for some specific use case, for some specific workload, and so on. And you may end up, and company, some big company which have databases, it's currently typically have growing zoo of the database management system it's used. So it uses Postgres for some purposes, for another purposes it uses Redis, it probably uses also MySQL, Oracle, and all this zoo it have. Next, when you are preparing a talk, it's always good to have some analogy from real life, and it takes a while for me to find this analogy of what is analogy of when you have a lot of database management systems. Imagine a kitchen where you can where you cook your food, and if you are kind of if you are not just cooking something very simple, right, but when you are cooking something sophisticated and delicious, you would likely have a lot of tools you are using to do this, and it's very difficult to keep all the different tools always perfectly ordered, right? Anyway, it's very easy to find yourself in a mess of various tools in your kitchen. This is analogy. What I mean is it's difficult for you to keep all your zoo of database management system in proper order. So you probably use some open source database management system, some commercial, and you will have to probably grow your own expertise, have support contracts, and so on and so far. So you need a lot of effort and to keep the data across a multiple database management system consistent, and it took a lot of efforts from you. The bigger number of database management systems, then bigger effort you need to keep everything in order. Yes, and could we have some universal tool to to keep the number of the tools small? Yes, to keep the infrastructure as simple as possible. Could we have something like this in database world? This is a question. This is a question I'm going to try to answer. Okay, and now I'd like to step a little bit back in time, and remember what was Postgres designed for. And this is a page from the paper from Stonebreaker about Postgres in the year of '91, and some ideas which was there already that time. One idea is orientation toward multilingual access. Idea that you can access your database from everywhere. That time, it was about having connection libraries for any language. But we can think about it a little bit more broader. We can think about it as having probably multiple interfaces to the same database. Teach your database management system to speak multiple languages, to be able to work with different protocols. What about this? This could, could simplify your infrastructure. If you could replace a multiple database management system with one speaking different languages. And another thing, this is another page from the same paper, and it also talks about some storage system innovation. Postgres initially have very innovative storage system with novel ideas, and these ideas was about handling more workload, more variety of workload, and handling modern hardware. That time it was modern hardware of that time, right? But we can keep the same idea for today. It's still the particular technical decisions isn't relevant now, but the idea to have some universal innovative storage system we can handle modern hardware and variety workload is still relevant, for sure. Okay, and also see how Postgres community growed since the early years. In Postgres in '96, Postgres was developed basically by this small group on this picture. Very limited number of persons, but I think it was easy to manage the development at that time, right? It was no problem. Everybody understands everybody. And what happens now? In 2022, we got 28 committers. Yes, it's much more than we have in 96, but still quite limited, amount. And if we see the stable release for 15 release, it's not yet published, but for 14, it was more than 400 contributors to release. So a lot of people involved into the development, right? But that's not all that we have in Postgres, because Postgres isn't just the single binary, not single binary, but single Git repository. It's the core, it's the heart of the system, but that's not all. We have extensions. And recently, someone have published the list of Postgres extensions on the GitHub. It's more than 1,000 extensions. This list attracts some critics by some reasons, but it's probably it gave us a big picture of how enormous is the size of Postgres extensions network. Yes, this is really enormous. This is the Postgres universe, and this lists only extensions, but there are also some surrounding projects which are not extensions, like connection poolers and so on. And I can highlight that there are some of them are super extensions which extends the possibilities of Postgres in a dramatical way. So these extensions, in my opinion, are Postgres, which adds geographical capabilities to Postgres, a lot of data types, functions, and so on. This CitusDB, which does amazing thing, which makes Postgres distributed database within an extension. TimescaleDB, this also makes Postgres distributed database for time series as an extension. And OrioleDB, which solves some long-term Postgres problems within an extension. And Oriole is a sample of this project. OrioleDB is a bird which comes in spring. The spring is a symbol of renewal, and OrioleDB will be the symbol of renewal, which helps us to have some new design and to solve long-term problems, which we all know for.
Yeah, okay, if I ask questions, like
sure, yes,
yeah.
Yes.
So you think, like, for these 4 super extensions, you think we know that for example, PostGIS plus timescale, it works perfectly, and people use it. Like, for example, if you have time series and you need to put everything on map, this is the best option. You think it will be possible to combine Oriole, for example, with Citus and have improved behavior of single node plus sharding, right?
Yes.
So like combination.
We didn't check this, but yes, it should be possible. Yeah. There is no ideology problem, and if even there are bugs, we will fix this.
Yeah, yes, Alexander Kukushkin sent me a link just before our talk that like showing that 10 hours ago Citus committed everything enterprise to open source. So now everything is open source. So it's becoming more interesting. I mean, to see combinations of these super extensions.
Good, very good. Yes, and what OrioleDB does, it's improves table access method. It's not just table access method which works within the existing framework, within the framework of block level write ahead log, of buffer mappings, and so on. It's an extension which we currently have some patch in the core, patch to the core, which we hope we can commit to version 16 or at least 17. And this patch contains set of improvements to API and set of hooks. Yes, and a small patch within less than 1,000 of lines of code. And thanks to that, we can do a lot of things, including undo log, index organized table, page level compression, copy on write checkpoints, row level write hand log, and so on. So we really handle a lot of things in a very different way than Postgres initially does. And that's very amazing that we was able to do this with so limited core patch, and we hope to become a pure extension soon. Yes, some tests, nothing new in comparison with previous talks. This was a test for write amplification, where in Postgres you update one index and you have to insert into all the indexes on the table, and OrioleDB allows you to change only one index. And thanks to that, a huge gain in throughput and IOPS. And also, OrioleDB does its best to save you from bloat. So it provides undo log and merge on sparse pages. And thanks to that, if you have a heavily update workload, it keeps your storage within a constant value.
What kind of workload was here? Like some pgbench writes or?
Yes, it's pgbench. It's some pgbench script. Okay, I can share the link. I already shared it with some slides, and probably we can.
It's possible to find it all details on GitHub, right?
Yes. I can put the link. Probably we can put the link to the video, right?
Mm-hmm. Sure.
Good. And also interesting experiment with Intel Upturn storage. Yes. So at first, OrioleDB eliminates some bottlenecks, which causes Postgres to degrade performance on high number of connections, including procal array, log, and others. And this is comparison of blue line with green line. But this too was working with Intel Upturn mounted as a file system, right? Working with file system, and file system have its own overhead. You have to do a context switch to access file system. You have to kernel works with its own cache and so on. But what you can do with Intel Upturn is that you can just it's just memory, persistent memory, which plugged into the bus, right? Like your main memory. And you access it through the bus, and you can just map this to your process address space. And once it's mapped to your process address space, you just read and write directly. Bypassing kernel, you don't need context switches and so on. You just directly accessing your hardware from your database, and that's amazing. And we have some experimental support for this kind of storage, and that gives us another 50% of performance, of read-write performance.
This workload was also read-write,
yes.
so
read-write.
it's not select only, definitely.
Yes, not select only.
Great numbers. I remember your post a few years ago about reaching million TPS. This was like 5 years ago.
Yes, but more it's yes, probably already 6 or 7.
It was around 9.6, 9.5, and improvements made there.
But that was transactions, read-only transaction, not
right. Select only was there.
Yes, select
much
only.
easier.
In single point selects, not very interesting transaction.
Right. This is different. That's already.
Yes, this is different, and this is not the best we can get from this kind of storage. This
but
is
it's so cool.
Experiment.
So cool. You scale to many working and conflicting clients and sessions up to 1,000, even more, and there is almost no degradation even on green line, and like I don't see degradation on red line, and it's it's great. Like you can scale.
Yes, you can scale the number of connections, because it's kind of spreaded opinion that you have the degradation due to number of connections because Postgres use process model. This is true, but the first problem, you have degradation due to internal logs. Only after that, with much higher number of clients, you have degradation because of processes. But the first thing,
these lines, if we have it on production, that means that if some spike occurs due to some trouble, we will sustain it better. We won't be down because.
But did you try that to compare to Postgres with some of popular connection brokers like pgbench or DCA or something like this? It would be like quite interesting how the blue line would look like comparing to those two. Then
this is a direct connection without any connection pool.
Exactly, because together with some traditional connection pooling system, like you usually use your Postgres, it would be interesting to compare.
Yes, it's interesting. It's worth trying. This probably will help the blue line, right? Because unpatched Postgres wouldn't have so many of writing transaction. But external connection pooler isn't the panacea. So it still uses the connection to the database, and it can't provide you. If your connection pooler, for instance, uses 100 of Postgres connection, it can't provide you more than 100 simultaneous writing transactions, right? So
right, I agree with you. I think Ilya thinks that this line, blue one, will improve with pgbouncer. I expect it won't, because usually it's improved when we deal with very small, brief, mostly like select only connections, very like under 1 millisecond.
When we're talking about some short updates, it improves too. That's why it was interesting actually to take a look and to compare.
Definitely 100% interesting, but I wouldn't expect big difference.
Well, we all know how badly Postgres default Postgres handles many connections, many simultaneous connections.
Working connections. Here, not idle, but working.
So
but still interesting,
It's not about like install pgbouncer and you don't need OrioleDB. It's about like it's interesting to compare.
So that's definitely worth trying. We will do this and update. Thank you. Okay. So yes, a little bit about OrioleDB consists of 2 repositories. The one repository is Postgres with extensibility patches, and the second repository is the Postgres engine itself. So OrioleDB engine itself, yes, it have more than 1,000 of stars, and everybody is welcome to come and contribute in the way you actually can. Sure. But let's think about what we can do, what also we could do to make Postgres a universal database, right? So one thing is a better OrioleDB engine. This issue, what we are trying to address in OrioleDB. Another thing is to make Postgres more suitable for analytical workloads. And for analytical workloads, at first we need an executor which should work better for analytics, because Postgres have the pool model for executor. It's a model where every node fetches tuples one by one. It fetches one by one from its getting, if needed, from children nodes and so on. But for analytics, where you have to work with a lot of rows, when you need to probably don't need the whole row, but quickly quickly calculate some aggregate and so on, you actually need to work with vectors and take advantage of CPU, vectorized instructions, and so on. And what we need here, I think, is it's a kind of vectorized slots inside the Postgres core, because it's possible to Postgres have a facility for pluggable executor, but this wouldn't be reasonable to rewrite the whole executor within an extension and trying to keep it synchronized with upstream very hard. Right. So
in this context, I have also a question, if you don't mind. OrioleDB recently released, like a couple of weeks released, Google released it. It's like their cloud offering, and they have an interesting idea. Have you seen it? They store like raw storage, but in memory they additionally transform it to column store only in memory, and this should help with analytical workload a lot.
Yes.
What do you think about it?
Yes. You need some columnar storage for data, but you also certainly need some columnar storage between the executor nodes, for sure. So if you have, if you have some page with vector of values, it would be ridiculous to push it through the slots one by one, right? You want to deal with this vector as a whole. And this is what we need. And columnar storage as well, and probably not the one columnar storage. But some vectorized slots, we need to utilize columnar storage. But columnar storage itself could be pluggable, I think, and we could have.
But you talk about storage like where data is stored on disk in columnar format, like in analytical databases.
Yes. That's it.
Yeah.
I mean, how it is stored in disk, but some ideas from LDB we could implement in OrioleDB as well. Right. That's it. And another thing we can do, and we certainly can do this within extension, is to make Postgres speak multiple protocols. So Postgres have user background workers facility, and you can write some worker which could listen Redis port, listen, for instance, Redis protocol, and probably spine some children worker to handle the connection, and being able to talk to, so being able to replace Redis, for instance, within the same database, speaking multiple languages. right? The same to GraphQL and MongoDB protocols. Why not? We can build the universal database which have multiple facilities to handle your data inside, right? Probably multiple storages, row-oriented storages, column-oriented storages, and at the same time it could speak externally in multiple ways, in multiple protocols, and that would be really universal database where you can replace multiple database management systems within one. This might, this might sound like crazy, but I think the way how we develop is always some kind of cycle. In the market, we have some period of growth where people start new businesses, new models, getting investments, and so on. And periods of crisis, right? Periods when the best models survive. The best that have been developed in the previous period survives. And probably in the database management system world, there is also some periods of pluralism, right? When there are multiple different systems are growing very fast. There are hundreds of database management systems, and periods of unification where people are tending to keep the number of solution small, right? To tending to pick one system instead of multiple.
There is already quite interesting and already published project by AWS here, Bubblefish, which speaks SQL.
Yes, exactly. Yes. We already have this.
Good example.
We already started this movement. And yes, we already have extensions doing sharding, right? This is this what we already mentioned, Cytos and timescale DB, and I think there will be more such solutions. And
both Bubblefish and Cytos are full open source, which is good. So like full members of open.
Yes, that's wonderful, and that's wonderful that Cytos Enterprise. I wasn't aware.
10 hours ago, commit happened, so it's very new.
Yes, that's amazing. That's just amazing that companies realize that they can benefit more from publishing open source rather than keeping the thing proprietary.
And because this company is Microsoft. It's very interesting.
Yes. Microsoft evolves a lot. Yes, people probably, there is always something that you remember from about. You always keep something in your mind when you are thinking about Microsoft. You kind of remember Windows 95, but that's completely different company now.
Yeah, speaking of licenses, let's bring something from chat. Alam commented that OrioleDB is licensed on traditional and permissive Postgres license. So
yes, it's Postgres license.
BSD-like.
Yes, we have no conflicts in licenses. That's also very important property of OrioleDB. That's no conflicts, and nothing prevents us from being one day even merged into Postgres core, and that would be very appreciated, but the different subject. And what I think about this, that we are going to, we already started the movement into the federated development model, right? Because Postgres core developers are doing a wonderful job right? To keep the code clean and keep technical depth low and so on. But we can see that this is limited. We can't scale core developers in the same velocity as we attracting more interest to Postgres, because more and more companies are interested in Postgres, in the Postgres development. Nowadays, you know, it's almost impossible to hire a Postgres developer for company. I'm speaking not just as a Postgres developer, but just as entrepreneur, right? And this is almost impossible task, because every time anybody from developers looking for a job, he very quickly got hired by some giant. Very quickly. But this happens because everybody wants to take part of development, and but ability to develop core itself is limited, and in order to took all the resources companies are willing to put into Postgres, we need the federated model, where it's not just core team working on the most important features, but we delegate very important parts of development, including the storage, the handling of different protocols and others. We trust this to some teams, and it's multiple teams working together to bring you an universal database which can handle very many things. I wouldn't say handle everything. Nothing can handle everything, but handle very many things. And I will.
I have a question about this picture. Yes. So don't you think extensions which are like, not all extensions are the same? So for example, extensions.
Yes,
extensions which
are the same. So there are extensions which doesn't change the functionality of Postgres dramatically.
Right.
But some super extensions where you not just dedicate extension to add some new data type or new function or
index,
new procedural language or new index, but some very important,
like new product already.
Yes, right. Like new product, like sharding, like.
My question is different. There are extensions which are quite small and provided with main distribution of Postgres contrib modules, right? For example, pgstart statements. And don't you think that they became a part of core so much that this picture doesn't work anymore, and they should put into like PostgreSQL core developers? I have an example.
Yes, but it's already here. Yes, so in this picture, I mean that this already.
Some extensions are inside the
yes,
center.
Some extensions are inside, because it's the contrib modules are not handled by some separate team. It's
right. The release cycle follows the main release cycle.
Yes, it's released. It have the same release cycles. It's maintained within the same team. It's within the same Git repository.
Yeah, we talked to Peter Zaitsev some time ago from Percona founder, and he answered, like, question was why they develop pgstat monitor, because the ideas from there could be brought to pgstat statements. And but his answer was it's much harder to follow this long release cycle. We need to move faster. So that's why they decided to create another extension.
So that's fine.
That's fine. Yeah, it's open source.
That's fine. Yes, for sure. Not everybody wants to making even, especially when this is kind of new product, quickly growing, quickly developing. Yes, and it's it's ridiculous at this stage to have one release a year, right? When you
it's too slow, and you are demotivated if you need to wait so much. You have a lot of new ideas, but yeah, like small interruption. We have more than 30 viewers online. I watching online. Who joined recently, please, I repeat this request to you, please share the link to this video in your social networks. It will help us to grow. Thank you.
Thank you.
Let's continue.
Yes, let's continue. And actually, I almost finished with the talk. Yes.
Great.
And the famous quote says that one size never fits all. But when we speak Postgres, I think if we are federated model with some super extension which give Postgres a very significant more functionality, then we can say that Postgres is one size, right? Postgres has many sizes. Yes, and many sizes can fit probably not all, but many sizes can fit many, I think.
Yeah, I also find it interesting that Stonebreaker said like 20 years ago or so, he said like one size doesn't fit all, let's create specialized database systems. But a few years ago, when he started to be a blogger in EDB blog, there was an obvious article, like I think against DynamoDB and MongoDB, that Postgres is great for various workloads. So he was against himself 20 years ago.
Yes, yes. I think this is exactly a cycles, right? And one point of cycle you're thinking about specialized solution, and another point of cycle you are thinking about unification. And Stonebreaker here, yes, formally he contradicts himself, but actually each time he speaks from the time he was speaking.
Okay, so we have a comment in chat also about from Alam about OrioleDB hooks have been backported to Postgres 13 currently on GitHub. So it works with 13, 14, maybe 15, right?
Yes.
Very newest versions. I have a question, since we don't have questions in chat, unfortunately, and I think everyone who is watching this recorded can ask a question in comments. I will be monitoring these questions. I have a question. You mentioned various problems and how Postgres will address them in future. But for example, in my opinion, MongoDB is still feeling quite well. Yes. In terms of market share and so on. We see that before current not best market shape, their market cap was quite big, more than $20 billion. So it's a sign that the ideas they have still make sense. And I distinguish two concrete ideas. First is like web scale, and we mentioned sharding. Right, so sharding is an obvious problem for Postgres, not fully solved. We have Cytos, now we have it more because it's fully open. They open source the main thing, online resharding or shard rebalancing, they call it. So this is good. Okay, somehow sharding is maybe solved, but the second message from MongoDB, it's called schemaless. I think it's not completely solved. You, of course, know very well JSON being worked on indexing, but for me, schemaless, its message is different. Not like let's put everything to JSON and forget about schema changes. We in a relational context, we still need good quality data quality. So we need to put some part of the data, at least not to JSON, but to normal relational columns. And then there is a big problem of schema changes. So what do you think, how this problem will be solved to simplify changing schema? And is it like, maybe I'm wrong, maybe it's not a big problem at all to simplify. For example, we have create index and we have create index concurrently. We have alter table and we have nothing to make to try to acquire a lock in graceful way, because if you try to acquire a lock, but auto vacuum is running in transaction ID wraparound prevention mode, we are waiting for this lock, and we start locking even selects to this table, because they are selects which came later are waiting for our attempt of acquisition. If we don't perform graceful retries with lock timeout, this puts our workload down. This is terrible, and right now it's not addressed at all, this problem, and every project hits this problem until at some point when it's quite big enough. So like I feel it very hard. This problem exists, but I don't see any plans to address it in current bigger.
Sorry, could you repeat a little bit?
So we are trying to add a column without any problems, like nothing, like not null, nothing there, just a column. And to add a column, we need a very brief exclusive lock. Right? What if auto vacuum is running in transaction ID wraparound prevention, so it won't yield, it won't kill itself, and it will continue running, thinking it's very important to perform transaction ID wraparound prevention, right? So our alter starts waiting.
Alter starts waiting, and it's
yes, all selects which came out, all selects inserts which came later, they're waiting for us. We accumulate like a line of waiting transactions, and this is bad. For indexes, we have create concurrently, reindex concurrently, drop index concurrently. We have it. For alter, we don't have anything, and there are many similar problems which are related to how we perform schema changes. And there is a gap between what documentation describes how you can perform schema changes and what you should do in heavily loaded environments.
Okay. I got.
It doesn't matter for analytical workloads because we can wait usually, but for OLTP, it matters a lot. And MongoDB says, put everything to JSON, forget about schema changes. That's it. You can do with Postgres, put everything to JSON, but usually you have something in normal columns as well. And schema evolution is a problem, right?
Absolutely, yes. I have already multiple thoughts on what we can do.
Okay, good.
Yes, at first, OrioleDB doesn't need vacuum to prevent wraparound.
Great.
This is one thing which improves the situation. Another idea I have that if we add column with not null, no default value.
Default is not a problem
in principle,
already.
We can do this concurrently to inserts, right? So
and selects.
Previous and
selects also matter. They
probably selects, yes, and select. Right. So yes. So inserts which are going to this table will just insert the tuples in old format, and that should be okay, right?
In some cases, right? Not maybe in all cases.
Because probably not maybe in all cases, but I think we can find some narrow case where we can do this without exclusive lock. Because tuple header contains the number of columns which actually in the tuple, and it shouldn't be a problem. So the queries which are seeing the older version of catalog should just ignore.
Because it's also in
extra columns we have. And
because catalog also follows MVCC of Postgres itself.
Yes. And what problem Postgres going to avoid with exclusive lock? It's trying to avoid the situation where multiple connections seeing different versions of catalog, different versions of the same table. So some connection will see this without new column, and some connections with new column simultaneously. But I think we can find some narrow case where we can do this without exclusive lock.
So it could be like alter table concurrently, or
yes, something like this. something like this. And the third idea about schemaless, that the idea is that we have to put some fields from JSON into columns because our JSON-B support isn't perfect yet. Yes, because if JSON-B is toasted, then it's toasted a whole, right? Because we don't have what we can have in principle. We can leave some fields in the table, but other puts into the toast table.
Yeah, for example, to enforce some constraints like uniqueness constraints.
To enforce some constraints, the fields which are most highly used for.
Guys, before we moved completely from the previous topic, we have a comment in the chat, which probably could be addressed to the things we discussed like a couple of minutes ago. So David Fetter has a note that as he is recalling, we already have the capability to take logs briefly, then we add columns in mainstream Postgres. And speaking of concurrently, he is working on a way to move that to background workers, so it doesn't chew up and depends on the client connection as it's currently organized in PostgreSQL. So some
ability to take logs briefly when we add the columns. It means like a log timeout. We set it to, for example, to 50 milliseconds, and then we need to perform retries. But this should be engineered for every time you want to do it. And I think, in my opinion, every project needs to engineer it. But it would be good. People learned about it after some failures already, usually.
As people do. And we actually have another question, which is a normal question. So Luca asked how stable OrioleDB is with respect to standard PostgreSQL. So
OrioleDB is now in alpha stage, and we hope we will get some stable release this autumn. But what we need is your help. I mean, everybody listening me. We need your help in testing it in order to reach the stable stage.
Actually, maybe some extra question based on this one. So basically, how is actually possible to measure the stability of quite a new project comparing to a project which is like 25 or how many years? So what, how you measure that, okay, we are now in alpha stage or we are in beta stage? What do you think?
Yes, that's the good criteria. Good question. I don't have some formal criteria for this, and it's like so. What alpha stage means that we are testing, we are attracting some people who are testing us, and we are faced some data corruption bugs quite frequently. And once it wouldn't be so frequent, we will switch to beta.
Okay.
Yes, and if you will, have some, if you have multiple workloads, multiple real life workloads, which would work stable for heavily loaded for weeks or something, we probably will say we are stable. But this is something, yes, something.
This is fundamental development.
I'm sure that wouldn't be the same meaning of stable as the meaning of Postgres core.
Yeah, this is fundamental development. It takes time, definitely. So
yes, absolutely.
Great.
Yes, and let me finish regarding the JSON-B. The reason why we have to put some fields from JSON-B into columns is that our toast mechanism isn't perfect. In principle, we can keep the most abundant fields of JSON-B in the table while putting the rest into the toast. without using columns, right? Just being this JSON-B. And there is a patch from Postgres Pro which addressing this. It would require for surely more work, but the work has been started in this direction, and I think this is great. Okay. Any other questions?
No questions. Like there is a discussion with David Feder about the future of create and recreate index concurrently, reindex concurrently. But yeah, you know this. Like it should today patched version for Postgres 14 should be issued. Unplanned minor version which should fix the big problem of create index concurrently and reindex concurrently in Postgres 14. So all Postgres 14 users should upgrade as soon as possible and check their indexes. And index management is of course a big problem, but indexes at least have concurrently worked. I see a lot of other cases. I wrote an article about it actually, about problems with schema changes. So that's why I'm asking. That's why I'm asking. Like, do you consider it also like a big field that can be improved? Good. Well, thank you so much. This was less about Postgres, about OrioleDB, but more about Postgres, and it was interesting, visionary, as you said, talk. Thank you, Alexander. Again, like I repeat my request to all people who watch this, please like, subscribe. Oh, more than 55% of people who watched previous episode watched it without subscription. So please subscribe. It's unfair that you do it. Please subscribe and share the link to this great talk in your social networks, and like and ask questions to follow up in comments. So we will be monitoring it. Thank you. Thank you.
Thank you.
Thank you.
Bye-bye.
Thank you.